All right, next up we've got scatterplots. So by the end of this lesson, my expectation is that you are going to understand how to be able to construct a scatterplot. Use your class pad to construct a scatterplot. Interpret that scatterplot. Understand scatterplots and association, and then association and causation and what that means. Okay. So we really have to nail identifying which of our variables is the explanatory and which is their response, because getting that correct allows us to construct an accurate scatterplot. If they are wrong, our scatterplot will be wrong and not give us the right visual for what we want to achieve. So scatterplot is used to investigate the association between two numerical variables, so have to be numerical. They are constructed on a Cartesian plane, so on your x and y axis. And the x-axis, so x-axis sits down low, is for our explanatory variable. If you remember that explanatory has an x-axis, an x in it, it sits on the x-axis. The response then sits on our y-axis, so y stands up tall, and the y carries our response variable. All right, so we may be given a table of values with our explanatory variable, our x, and our response variable, our y. And to then plot these, we have our origin here, which sits at 0, 0. We've created a scale on our x and y axes. Can you see that each of these values sits on the actual line in this graph for both the x and the y? So to plot these points, we're going right back to plotting on the Cartesian plane. So we walk across for our x value first, so our explanatory, and then climb up to plot our y value. So our first coordinate that we're plotting is 5, 10. So we walk across 5 and climb up 10, and that plots our first data value. All right, so then we go to our next set of coordinates, which is 5, 12. So from our origin, we walk across 5, climb up 12, and plot our point. We go and we do that for each value in our table. All right. If you're using the class pad, here are the instructions. So you're going to open menu and open the statistics application, and you need to clear all your lists. So you need to take your values out. In the table, so list 1 and list 2 is what we're going to use. All right. I would say that you are plotting, so here, let's think about it. So if we've got temperature and number of drinks sold, which one is going to explain the other? All right. So in this instance, our temperature is what we think is going to explain the number of drinks sold. Okay. So these are hot drinks specifically that we're selling at the milk bar. So we're thinking that as the temperature increases, the number of hot drinks that we sell decreases. And so we're going to plot that in a scatter plot to see if that trend holds. Okay, so we've got our temperature here. So our temperature being our explanatory, and our number of hot drinks sold, our response in our y. All right, so we've plot all of those. Now, it's really important when you're doing this that you are lining up the correct x and y. So they have to go in order. So 35 degrees correlates to 25 drinks sold. So you can't plot the 35 against the 54 because that's not the value that they're not the values that we're getting from our data table. So make sure that you accurately put them into your class pad. We're going to hit graph, and we are going to produce a scatter plot in the lower window. all right? And that will give us our scatter plot, all right? So next up, what we are going to achieve is we're actually going to start interpreting what this graph means. So let's head down. Have a go at that yourself. So pause this video. I want you to graph this data in your class pad and see if you achieve these results here. All right. Now we're going to move on to interpreting scatter plots. So the whole point of putting data into a graph is so that we can draw some kind of meaning or interpret it in a really easy manner. If I just look at data in a table, I'm probably not going to see patterns or trends that I would if I had it in some kind of visual format like a graph. So a scatter plot is a great way for us to, I guess, make some assumptions about our data to a degree. So this is called interpreting a scatter plot. We need to understand what each of the variables represents and how it's measured. So here we go. Let's have a look. We've got a study that was conducted on how long people of various ages spent at an exhibition at the Melbourne Aquarium, and a scatter plot was plotted of the data. So we've got age across our x-axis and time on our y-axis. So our explanatory variable, which variable is on our x-axis, and that's age, and our response variable is on our y, which is time. So we're thinking that age explains how long you spend at the exhibition. How many people were in the study? So to find out how many people were actually tracked for their data, we just need to count up the data points in our graph. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 people were viewed for this data. So what does the orange dot represent? So we've got this orange dot here. So let's read the data on our x-axis. So it's sitting against 15. So this data point represents a 15-year-old. And on our y-axis, it sits at 10 minutes. Okay, so this data point represents a 15-year-old who was at the exhibition for 10 minutes. How many teenagers were in the study? So we've got here, so this is 10. So we haven't got all of our little points put here. So we haven't got 11, 12, 13, 14, up to, we've got our 15. I'm saying this would be a 14-year-old because it is very close to the 15. So we've got a 14-year-old, and then the next lowest to that is a 10-year-old. So a 10-year-old doesn't classify as a teenager. So 14 and a 15 and a 15. So we've got 3 so far. This could possibly be, this is a 19-year-old. So that's one. So that might be an 18 or 17-year-old. So that's another. This person is likely 21, so they're not a teenager. So we're saying 5. So 5 teenagers were in the study. What was the shortest time spent at the exhibition? So we're going to look on our y-axis and where our lowest data point is, and that sits at 5 minutes. So the shortest amount of time spent at the exhibition was 5 minutes. All right. Here's where we get into the nitty-gritty, and this is really what forms the basis of lots of your work in Unit 3. So scatterplots and association. There are 3 ways that scatterplots can be used to describe the association between 2 numerical variables. So we can have a positive association, okay, that the response variable tends to increase as the explanatory increases. We can have a negative association, so that will fall away. So it indicates that the response variable tends to decrease as the x or the explanatory variable increases. All right. So that's one of the ways that we can describe association. We've also got form. Okay, so far we've had direction, now we've got form. You've got linear. So it generally follows a straight line pattern. You've got non-linear, where it does have a straight line pattern, but it does follow a curve pattern. And then you've got no association, so it's quite random and scattered. So far we've got direction and form, and then we go to strength. So you could have a strong association where all data points are reasonably close together. Then you move to a moderate, where they're a little bit more spread out, or weak association, where they're quite widely spread. But can you see that there's still some kind of shape to that scatter plot? So remember, you've got 3 ways to describe. You've got direction, form, and strength. These are things that you are going to have in your notes, so make sure that you've really clearly got these with examples about what each of them means and what they look like. So for each of the following, you need to describe the association between the 2 variables in terms of direction, form, and strength, and then explain what it means in terms of the variables. So we know what each of these variables is because it's labeled on the axis. So if we look at car speed versus distance to destination, we've got a negative relationship. It's linear and it's strong. So see how it's really tightly bound together. So as our car speed increases, our distance to destination decreases. Okay? Or the distance to our destination decreases as car speed increases. All right? For B, we've got no association. So we can't talk about if it's got a direction. If there's no association because it's got no sort of shape to it, it really doesn't have a strength, and it also will be unlikely to have a direction because it's so scattered. It just has no kind of shape or rhyme or reason to it. So that really means that the amount of tea drunk has very little association to the time spent exercising. All right, there's not really any correlation between the two from this scatter plot. Okay, if we look at foot length and hand length, we've got a positive relationship. All right, it is linear. It's got a shape to it that's linear, and it's probably more moderate. So you can see it's still got a bit of scatter to it. So as foot length increases, hand span tends to increase. Okay, sorry, as foot length increases, hand span. So hand span tends to increase as foot length increases. Can you see the slight difference in the wording? It's the foot length that explains the hand span. Okay, it's the foot length. So it's not as hand span increases, foot length increases. When I say it like that, that means that hand span is explaining foot length, which would be incorrect. All right, and our last one here, we have got a negative relationship. There's still a bit of shape to this. It's still linear because we have got that shape. It's not as scattered as this one, but it would be a weak association because it's just not as tight as it could be. So can you see the difference in the wording here? So we've got the word tends to for moderate, and we've got some evidence to suggest that weight decreases as your time spent exercising increases. So be really clear on the type of language that you use. These are good examples to have. All right. The last one here, we've got association and causation.